Welcome back to Maths with Mrs. J. I thought it was time for us to do another challenge question. This one I'm going to call a 3-star challenge question because it really is quite tricky. It does, however, involve only the sorts of algebra that you should be able to do in the senior years of high school. It doesn't require university level maths. However, as I said, it is very tricky. We're given these 3 equations. We're told that a plus b plus c is 1, a squared plus b squared plus c squared is 2, and a cubed plus b cubed plus c cubed is 3. And we're asked to find the value of a to the 5th plus b to the 5th plus c to the 5th. It's not 5, by the way. It's not like one of those pattern questions where you just follow the pattern. It's not going to be 5. It's going to be a lot more complicated working out than that. Okay, we are at liberty to use these bits of information here as much as we need to help us get to our goal. So I'm going to call that equation 1, call that equation 2, and call that equation 3, just so that we can refer to them. Now we've got to start thinking about this expression, a to the 5th plus b to the 5th plus c to the 5th. How are we going to get an expression that involves those terms? We do have a few options. We could do a plus b plus c all raised to the 5th, which is relatively easy to do if you do it like that and do a to the 5th plus 5a to the 4th times b plus c, etc. Do your binomial expansion where that's sort of like your second term, and then obviously you expand that bit out. That's going to be a mess though. You're going to get a lot of terms and it's probably not going to be the easiest way to do it. So we might just sort of put that on the back burner for now and see if we can find something that might not be quite so complicated. We don't want to have too many terms to have to kind of simplify. What could we do? Well, we've got a squared, b squared, c squared in that expression and a cubed, b cubed, c cubed in that expression. So how about we try a squared plus b squared plus c squared times a cubed plus b cubed plus c cubed. There's no reason why we can't do that multiplication. We will end up with these 3 terms. We will, of course, get other terms as well. Don't just think you're just going to get those terms. However, let's see what we get and see how it helps us. So you're going to get 9 terms here. This one times those 3, this one times those 3, this one times those 3. So we're going to get a to the 5th plus a squared b cubed plus a squared c cubed plus your b squared a cubed plus b to the 5th plus b squared c cubed, and the remaining 3 terms c squared a cubed plus c squared b cubed plus your c to the 5th. Now we've already ended up with the 3 terms that we were looking for, so let's bring them out the front and put them together. That's good. What are we going to do with these remaining 6 terms? How can we maybe put them into a way that we can then find out the value of those? Because we know the value of this, that's 2, that's 3, this is what we're trying to find. So if we could somehow knock the rest of this into a shape that we can find the value of it, then we'll be all good. If you're having a look at these 6 remaining terms, you might notice that we've got an a squared b cubed and an a cubed b squared. How about we write them next to each other and see what we're going to do with those in a minute. Let me just write this, a cubed b squared, sorry about my writing, plus, and then you've got an a squared c cubed and an a cubed c squared, which is this term here, and then you've got a b squared c cubed and a b cubed c squared. Now what we can actually do here is we can take out, so we'll leave this out the front as it was, our a to the 5th plus b to the 5th plus c to the 5th. We want to keep that together because that's what we're trying to find, and we already know what that is and we already know what that is, so that's all good. Let's see what we're going to get here. I would be inclined to take out an a squared b squared out of this. And then what have you got? B plus a. Okay, then we've got, take out an a squared c squared, and we've got c plus a. And then a b squared c squared, and we've got c plus b. What are we noticing here? Hopefully we're noticing something. These expressions here, if we go back to this first equation, we know that b plus a is going to be 1 minus c. Okay, so we're going to sub, maybe call that equation 4. So sub 1 into 4, and we get that that equals, so we've got our a squared plus b squared plus c squared times our a cubed plus b cubed plus c cubed equals what we're trying to find, plus a squared b squared times 1 minus c, plus a squared c squared times 1 minus b, plus b squared c squared times 1 minus a. Now what's going to happen here is, we can obviously sub in information from 2 and 3. So we know that 2 times 3 equals this expression plus a squared b squared minus a squared b squared c plus a squared c squared minus a squared c squared b plus b squared c squared minus a b squared c squared. What's all this business going to give us? Well, 6 is this. And then what have we got? We've got all of these double, I'll call them double square terms. So we've got an a squared b squared, an a squared c squared, and a b squared c squared. So let's put them all together, because there hopefully will be a way that we can work out what they are. And then the rest of these things here, what have we got? Well, we've got an ABC is a common factor in each of those, isn't it? So we can take out a minus ABC, and then to get it to work, we're going to have to multiply that by AB. We'll have a plus here because we're subtracting this as well, plus an AC plus ABC. Okay, let's just call that maybe equation 5 for now. We are actually making some progress. It might not seem that we are, but we are. So we've got 6 equals this expression that we're trying to find. So that's all good. We've now really got 3 things that we need to find expressions for. We need to find an expression for what I call your double squares, your a squared b squared plus your a squared c squared plus your b squared c squared. We need to find an expression for what ABC is, and we need to find an expression for AB plus AC plus BC is. I reckon we can do that quite easily. Well, maybe not easily, but we can certainly do it using these original equations here. Okay, let's think about this for a minute. We'll have to move on to the next page, unfortunately. There we go. Okay, so we need to find, let's just write a little list of what we're hoping to be able to find. So we need an expression for ABC. We need an expression for a squared b squared plus a squared c squared plus b squared c squared. And we need an expression for AB plus AC plus BC. They're the 3 things that we are looking to find in order to substitute into that very important equation that we left our previous screen with, which I'll rewrite up here. So we came up with 6 was our a to the 5th plus b to the 5th plus c to the 5th. And what did we have? We had that's right, we had plus those a squared b squared plus a squared c squared plus b squared c squared, and we also had minus our ABC times our AB plus AC plus BC. I'm going to underline these in different colours. So this is what we're trying to find for the question. This is something that we're going to try and find. This is something that we're going to try and find. And this is something that we're going to try and find. If we can find expressions for all of these, we can sub in and then we can work out what we're dealing with. Okay, let's go back to the very beginning. My first thought when I saw that a plus b plus c is 1 was I thought, well, why don't we square that expression? No reason why we can't square the whole expression and see what we end up with. So how would I square that? To do this, I do a plus b plus c squared. Obviously, that's 1 squared. Doing it this way, we get our a squared plus our 2a times b plus c plus our b plus c squared, which is a squared plus 2ab plus 2ac plus b squared plus 2bc plus c squared. Bring all our a squared plus b squared plus c squareds next to each other. So this was just 1, well, it's 1 squared, which is 1. Plus, and we've got 2 lots of our AB plus AC plus BC. Ooh, that's been good. So, we know that that is 2 from our original equations. So, we know that 1 equals 2 plus 2 lots of this expression here. This is great because it means that we can now find what that is. Take 2 away from both sides and divide by 2. And we get that AB plus AC plus BC is -1/2. So we've already ticked off 1 out of our 3 things that we're trying to find. Let's call this equation. I don't know what equation we're up to. Probably equation 5. Okay, so what else are we going to do? We're hoping to find an ABC and we're hoping to find these squares. How are we going to find an ABC? If I do our A plus B plus C times A squared plus B squared plus C squared, let's see what we're going to get here. Again, you're going to get 9 terms. So you're going to get A cubed plus AB squared plus AC squared plus BA squared plus B cubed plus BC squared plus CA squared plus CB squared plus C cubed. Again, let's put all our cubed terms together because we know what that equals. And then what are we left with? We've got an AB squared plus a BA squared, so plus an A squared B. We've got an AC squared plus an A squared C, and we've got a BC squared and a B squared C. We did something similar to this over the other page, and what we did was, just put a line down here so we don't get confused where we're up to. What I did was I took out an AB out of these, and we're going to get B plus A. I took an AC, well, we did something very similar to this anyway over the page. And then we remembered that from our A plus B plus C as 1, we can sub in B plus A will be 1 minus C, C plus A will be 1 minus B, and C plus B will be 1 minus A. This is looking good because it looks like we're going to get an expression happening for an ABC here. Okay, so that's 1 times 2. So 1 times 2 equals 3 plus AB minus ABC plus AC minus ABC plus BC minus ABC. Oh, this is good. Okay, so 2 equals, so negative 1 equals AB plus AC plus BC, and we've already worked out what that is, which is fantastic, minus 3 lots of ABC. Oh, this is cool. Okay, so let's sub 5 into 6, and we get that negative 1 is negative 1/2 minus 3ABC. So 3ABC is 1/2. So ABC is 1/6. Cool. All right, so we've now got 2 of the 3 bits of information that we needed. We've got that. We've got that. And all that we've got remaining to do is this in purple here, the A squared B squared plus A squared C squared plus B squared C squared. How are we going to do that? Okay, what do you think might be a good idea there? How about we do our A squared plus, oh, I know what we'll do. We've got this expression here. Why don't we square that expression? Because that will give us an A squared B squared, an A squared C squared and a B squared C squared, and some extra stuff. The extra stuff we can hopefully deal with. So let's have a look at this. We're going to have to turn the page yet again. So AB plus AC plus BC is negative 1/2. I'm going to square that. So that's obviously going to be 1/4. So we're going to get A squared B squared plus 2AB times AC plus BC plus AC plus BC squared equals 1/4. Okay, so A squared B squared plus 2A squared BC plus 2AB squared C plus A squared C squared plus 2ABC squared plus B squared C squared equals 1/4. Now, all of these things are what we're looking for an expression for. So let's put them all together. And then our remaining terms, we've got 3 remaining terms, and we can take out a common factor out of those, can't we? So then we've got plus 2ABC, and we've really just got an A plus a B plus a C. Oh, this is good. This is good. Okay. I don't know what equation number we're up to. Let's just have a look here. We're up to equation number 8. We know what that is. We know what that is. So we can now get an expression for this. So this business here, our A squared B squared plus A squared C squared plus B squared C squared plus, well, what was our ABC? I'm pretty sure our ABC was a 1/6, wasn't it? So 2 times a 1/6 times A plus B plus C was just 1, and that all equals 1/4. 2 times a 6 is a 1/3. So this stuff is going to be 1/4 minus 1/3, which is negative 1/12. Now this is really cool because we've now found the 3 remaining things that we needed to find to sub in to that big equation we started out with. Okay, let's press on. We'll just sub it all in and we should get an expression in no time. So what we had for our initial expression was, we said that, let's get the right colour here. So we said that 6, well, we had an a squared plus b squared plus c squared times a cubed plus b cubed plus c cubed, and we got a to the 5th plus b to the 5th plus c to the 5th plus these ones minus ABC times AB plus BC plus AC. So that was our sort of critical point there. We can now sub in everything that we know because we now know every part of that. That was 2, that was 3. This is what we're trying to find, so leave it there. Plus, all of this stuff here is your negative 1/12. We just found that on the previous page. Minus ABC was a 1/6. And AB plus BC plus AC, what was that equal to? That was negative 1/2. So we get 6 equals this expression minus a 12th plus a 12th. So, lo and behold, a to the 5th plus b to the 5th plus c to the 5th is just 6. How cool is that?